Welcome to the latest Mobile Forensics Explainer episode, Android edition. I'm really happy for you to be here. My name is Alexis Briggs Brignoni, and I am the main developer for the ALEAPP tools. And the ALEAPPs are tools designed for triage of your mobile forensic images, iLeap and ALEAPP. And today we'll be discussing ALEAPP in the show on one interesting artifact that I think will help you in your investigations. First, before everything else, we need to get the tooling to be able to get some benefit out of this. So if you want to get the ALEAPP tool to parse your Android extraction, you can go to my GitHub. I misspelled here the address. Let's just fix it on the fly, right? It's a good thing about being live. It's Brignoni. I correct my last name. There we go. So you can go here and get the tooling. It's Python based, and I will be putting a link in the notes on how you can download it and run the tool. Really easy. Courtesy of Exordia, company that's done on some educational videos and has a good video on how to run the tool. Second thing you will need after the tooling is test data to be able to try it out. I highly recommend Josh Hickman's test images. You can find them there at the binaryhig.blog, public images. Download the Android version. Today we'll be using his freely available test image or extraction for a Android 13 device, right? Perfect. So with that being said, let's get into the topic of the day. The topic of the day is images need context. And what do I mean by that? I want to bring your attention here to a pretty interesting article by the Lehigh Center blog in Champlain University. I'm going to share that with you so you can follow along. And when we do our examinations using our tooling, our tools tend to do this. If there's images in the extraction that we're examining, it just puts them all in a big category called media or images or whatever it's called, right? And with that, they give you the picture. And actually, I'm going to zoom in here for an example. Like you see on screen, give you a picture there. So the image that it was recovered by the tooling, the name, some metadata, creation dates, and the like, and the path where it came from. And that's it. Okay? In some instances, your tooling might aggregate those images because of their significance. And I believe that significance, that context is really important. One of the reasons I made this specific artifact or a specific set of images is for that context. One of those is the image manager disk cache. And let me put it here on the screen. And you might have come across these images within these directories. And I'm going to zoom in further into the picture. You can see it. Look there that you have that coffee cup picture, and they're in red, image manager disk cache. Okay. And a really long file name that ends in .0. What does that mean? Just by looking at that. No idea, right? Let's discuss it. So based on my research and the research, publicly available research, you will see a couple of things. You will see these folders, image manager, disk cache folders within all sorts of applications, right? And they're going to be contained the following path: the data folder, right, where the user data resides in Android devices, the bundle ID of the application, that's the name of the application or the app that's internal to the phone or the device, right? I'll give you some examples in a minute. Then there'll be the cache directory, then the image manager disk cache directory, and within it, these really long file names, a combination of different letters and numbers that end with the .0 extension, okay? The reason you see this type of structure there is because the application is using a system called Glide to manage the image caching within the app. Let me show you here. What does that look like? So Glide, and it tells you here in their page, and assuming as well, it's a fast and efficient image loading library for Android focused on smooth scrolling, right? So when your applications receive data, or you put data in them, data in the sense of media files, Glide is used to be able to load those images within the application. That's really important because it tells you something about why are those pictures there if you start giving you that context, right? The next question you might have is, well, that's all good. We know that media comes in and out of the application. If it uses Glide, it places those images in this image manager disk cache directory. What about the weird file name? And what does that tell me? One of the first things I tried to do when I found these images in this directory is see if I could correlate them to the activity within the app. Maybe find the name of the file, of the picture, that original picture that was generated within that cache, right? And I found the following looking at the documentation, and I put it there on the screen as well. And all those will be part of the notes. Glide, when it creates those file names, uses an interesting and complex algorithm. And let me focus your attention on that. It says here, so Glide, this system to cache images as they're being either received or sent through the app, it will look for certain things, right? It would look for what is called the cache keys. That means how the load that is requested for the file, and we're not going to discuss this in details for you to kind of do your own validation on this. You can look that on your own. It needs an optional signature, the width and height of the image, the transformation, different options, the type of data. Now this is the important part. I'm going to highlight this part here on the screen. To generate the name of this cache keys on disk, don't worry about it, it's coming. The individual elements of the keys are hashed. This is the important part. To create a single string key, which is then used as the file name in the disk cache. This means that all these elements we just mentioned briefly are put together and hashed in a specific way that creates that file name for that file in that cache. What's the problem for us? There's no clear way of reversing that process. As you can see, it requires different data points that we will not have access to it. So that's the bad news. The good news is that through our research, we can obtain context to those images, additional context. Again, we know it's Glide, we know it's coming in and out. What other context can we derive from this images? So I'm going to drive now again your attention again to some research done that's available. The first one tells us a little bit about how are these images cached, when, and for what reason. And I think it's really important that we look into that. Let me get the right link here. Right, so right, let's share that with you. Yep, here we go. All right, so let's look at this article. Let's look for the cache section here and zoom in so we can get understanding of when is those created. So there we go. I'm going to highlight it on the screen so we can follow along. Cache files were also, and this is in particular, this is the Signal application, right? Cache files were encrypted and stored in the cache image disk cache folder. Now, multimedia files are created when we send or receive them, while cache files are created when they're displayed on screen. All right? This is an important data point. For different applications, these files, if you find them there, are created when they are displayed on screen. So it tells you some context about those pictures. Let's look for another example here, also based on research. There we go. So let's look for this one. And this is a pretty good source. This comes from the Department of Defense cyber website. And this is an analysis they did on a photo vault app. What that does is it's an app that behaves, let's say, like a calculator, but in reality, it keeps pictures encrypted within it in order to hide them from prying eyes. And this is what they found. They found that these applications that use Glide, and look what happens. Calculator Vault Hider catch up images that are still stored on the device, as well as images that were deleted and not stored or hidden in the DCIM folder. What is that? The image manager disk cache directory keeps those images even after they were deleted, keeps that cache copy of them, right? This is really important. I'll give you an example, real example in a second with the image, so you can see that in practice, right? Last example from the research that you can use it as a starting point for your own research. Let's look at this other article here. And on this one, they were doing some analysis on streaming platforms like Twitch and the like. And these applications within the Android clients also used the cache system we're discussing from Glide, right? Let's see what they found. These pictures here that were obtained from the cache, and it says the images correspond to every Twitch stream which is listed, and when a search is performed, the stream categories which are listed and the profile pictures of each channel. Then images from the replay streams are cached as well. For a video replay, several images corresponding to the view stream were cached. See the pattern there? A previous cache for the rest of the listed streams, right? And in order to establish the time in which streams have been viewed, creation, modification, and last access timestamps of cached images needs to be examined. So notice, it requires that user activity to access the streams, open them, do the searches, go to the different accounts to see the profiles. So now it tells me some context in this particular app about how these cached images were created, utterly based on user activity. So now you can see these images, you have them in this directory, and now you can confidently say, well, these images at this particular point in time were generated, and based on the content of the picture, you may even tell why. And notice how we go from having just a picture sitting in a folder we don't understand to providing a full picture on context. Because again, the main point I want to leave you with is that context. Context is key. All right. Perfect. So we understand the artifact. We know what those images are in those directories. We know they're related to Glide, that caching system for images coming in and out. And depending on the application, they could be directly generated by user activity. It helps with attribution. Let's give an example within the tooling. So what you do with the leaves, you're going to execute them, which I'm going to do right now. And I'm going to show you the main screen there for the leaf. Right? So what you will do is you will deselect all these artifacts and look for the artifact in question. We're going to go to the eye really quickly, right? Get past it. There we go. And we're going to get the image manager cache artifact. You're going to browse for your here on the top for your extraction. Then you're going to browse for the folder you're going to locate them. Now, like a good cooking show, in order to save on time, I'm going to show you the end product. Okay? So we can then discuss the example here. So I'm going to share with you the directory where I place the report after running the program or the scripts. As you can see here on the screen, you see the report directory, ALEAPP. and when it was ran today. And let's look at the contents of that folder. You have here the index.html, which will open the main report window, okay? And then the different artifacts that were parsed. In this case, we're interested in the image manager cache. Now, the temp directory, since I ran the extraction from a compressed data source, it exports the data from the extraction, makes a copy for you for later review. So I want to show you how in the data directory, for the different bundle IDs that you can see here, data is kept within the cache, image manager disk cache. You see that? That's how it looks on your system. The tool pulls it out in case you want to do a manual analysis of those files. And for this example, I want to highlight the com.thinkyeah.gallery vault. And notice it has a cache directory and an image manager disk cache with multiple images there. You might ask yourself, well, that bundle ID, that com.thinkyeah.gallery vault, what is that? So I'm going to give you a cool trick here. If you see a bundle ID, an app that you never heard that name before, you can always go to the play.google.com store and look for any app. And whatever app comes up, at the end of that URL, it will say ID equals and the name of that bundle ID of that app. Substitute it with the one that you are not familiar with, and it will take you to the app itself with the proper name. Let me give you the example here for the one that we're researching or studying right now. Okay. Notice here how this app is a gallery vault hide photo video. So that's the name that it's given within the Play Store, but internally, if you look at the URL, is the one that you see here on the bottom. It's com.thinkyeah.gallery vault. And what do they say they do? Let's zoom in. They say they protect you. How? Gallery Vault is a fantastic privacy protection app to easily hide and encrypt your photos, videos, and any other files that you do not want others to see. That's what the tool says it does. Okay? Now, let's go now to the tooling. The tooling extracted images from that cache and it makes a report for you. How does that look? I'm gonna go open directly the report itself. You see here the report, and you see there the main screen, and on the left you see the image manager cache icon there for the images that were converted, right? So let's give it a second there. Perfect. So now you see the different images. The last modified time, the image, the file name that we discussed, how it's generated, and the path where it's located. Now I'm going to focus on that Vault app. So and we said the name was what? Think. Yeah. Oh, I misspelled think. Why? That's enough, right? So we see the gallery vault, some of the icons. All this is inside that image manager cache, right? Use some icons for different things. But now is where it gets interesting. And actually, let's select all, so I don't have to go page by page. Select all. And at some point, you start seeing things like this. Can you see that on screen, right? We're seeing those images, right? It keeps the cache versions in them. It's a person that well known to us. And there's different copies for that based on the extraction and the data folders that they're in. But I think that illustrates the point, right? Now, these images that might have no meaning, now we can start putting the pieces together of cache data using this glide system. And based on the testing, user attribution generation. And you might see those pictures now in the clear, where before you wouldn't have access to them, okay? Again, I hope this brings home the understanding that, again, context is key. Context is key. Context is key. And just seeing pictures in a library of media without that context, it won't really help your cases. So ALEAPP does this for you. You as an investigator, if you see pictures in the media categorization, look at those paths. Try to understand where they came from. What's the context? And when you find it and your cases benefit, make sure to share it with others. You can contact me, other researchers in the space, and we'll be happy to add that to our tool, right? Again, with that, I think that's enough for today. Thank you so much for your attention, and hopefully this helps push your investigations forward. And with that, thank you so much and have a good day.